Welcome to Data Skeptic. Data Skeptic brings you discussions about how data is changing our world. Our interviews are conversations with thought leaders in topics like data science, machine learning, and artificial intelligence.
Hey listeners, as you heard on last week's episode, we've concluded our series on artificial intelligence. Now, it's not the last time that topic's going to come up on the show. In fact, there's a couple of bonus episodes that are going to hit the main feed soon. But for the main focus of the show, everything's about to change. This Friday, our new theme begins. Tune in for a whole new Data Skeptic. For today, I'll be speaking to Paige Bailey and Damien Brady about deployment and DevOps for data science. After the break, Damien Brady comes back and is joined by Donovan Brown for a continued discussion specifically about change management and databases. You know, there's lots of opinions floating around about exactly how data scientists should be doing their jobs. Plenty of people will tell you what's absolutely right and absolutely wrong, and very few of them will agree. In my opinion, there's no one right answer. Of the myriad of tools and approaches, there's some things that are commonly good, like I'm all in on Docker for sure. But beyond that, a lot of the choices get difficult. These conversations explore that topic, but I'd like to hear from you guys too. Stay tuned to the end of the show to hear what I'm talking about on that front. Well, I'm joined today by Paige Bailey and Damien Brady. Thanks for joining me.
No problem.
Thank you. We're happy to be here.
To get started, would you give me a little bit of a sense of your background and your roles at Microsoft?
My name is Damien Brady. I am a cloud developer advocate on the DevOps team at Microsoft. So where Paige is all about the machine learning AI stuff, I'm much more on the dev and DevOps side. So I'm just dipping my toe into the water of machine learning and AI. Helped actually a fair bit by things that I've learned from Paige and her colleagues Seth and Vadim and David as well.
So this is perfect. I'm kind of the exact opposite. So I'm also a CDA, specialized in machine learning and AI, as Damien mentioned. I've spent the last 10-ish years doing machine learning models and data analysis. So worked as a data scientist before I came to Microsoft. But I'm just dipping my toes into the DevOps space. So Damien's been helping me understand best practices and then also how you would go about implementing all of the artifacts that you have as a machine learning practitioner in VSTS.
So if we said we were going to discuss DevOps for software engineers or for mobile engineers, I think it would be much more clear what we were talking about. You know, yes, there's a variety of tooling, but everyone gets basically the same workflow and agile and that kind of thing. Data science is a whole other animal. I mean, it means different things to different people.
Absolutely.
What does DevOps for data science mean?
DevOps for data science would look a lot more like making sure that your inputs to a model, so all of the data pipelines that you built, are standardized. So you want to make sure that the images that you insert into your model are all of standard resolutions. They might all be of the same dimensions or have the same color spectrums. You also would want to make sure that the data that you're sampling is coming in at a consistent rate. So for example, if you built a model using sensor data that was coming in every 10 seconds, and then suddenly, you know, your requirements changed for your business and that data came in at a sample of every 1 second, that would probably impact your model considerably. So you would want to make sure that those checks were enforced. And then also for the deployment aspect, you have to keep reevaluating your model to make sure that your accuracies are still there. So you might have 95% accuracy in March, but as time progresses, that accuracy might go down, or your F statistic might change, or your business requirements might change. And unless you're doing that constant reevaluation cycle, your model's no longer going to be effective and meet your business needs.
Yeah, so DevOps is generally about this pipeline and this automated pipeline, ideally, of getting from an idea to something running in, you know, your real application and monitoring how that's performing and feeding that back into the cycle as well. So there's a lot of crossover points here where it can definitely assist in data science and machine learning as well. And even just practices from dev and from DevOps, like making sure that all of your stuff is in source control.
Absolutely.
Which is one of those things that I think sometimes gets overlooked in this arena, right?
Well, and data scientists have the wonkiest naming convention extensions too. It's like untitled Python, untitled 24.ipynb sort of. There was a meme circulating about that recently.
Yeah. I think I saw that meme. That's pretty funny.
Absolutely. And most of our artifacts aren't in version control ever, because if you're a data scientist, often you're working in an isolated space. You're trying out a lot of different models, you're iterating over them, tuning hyperparameters, and then maybe the final model is saved. But all of the iterations that you have until you get to that final model, it's not. And I'm not endorsing that method by any means necessary, but it's just something that I've seen that's kind of scary that happens often in the data science community.
Paige, the sort of life cycle you were describing earlier of, that data scientists are working a little bit different than software engineers. Ultimately, though, they come up with some sort of artifact. Maybe it's a TensorFlow model or a CNTK model, something from sklearn, who knows what. Lots of variety, but we could draw an analogy between that and the binary of some compiled software. Do we treat everything the same from there on out? Can we just run QA and deploy, or are there added steps for machine learning people to look at?
So the ideal situation that you would have for a machine learning model is that you would package it up as a container, right? And then once the model's been containerized, then you can call it as a REST API. Like it's a great endpoint for software application developers to connect to, the same way that they would connect to any other RESTful cognitive service. If you've experienced that from Microsoft, or AWS has Recognition, and Google has their own versions of RESTful machine learning services as well. But the ideal state, get it into a container, get it into something that a software engineer knows how to incorporate into their application.
Yeah, in that CICD pipeline that we talk about, continuous integration, continuous delivery, or continuous deployment pipeline we talk about in software, the CI component is the output of that is this artifact, ideally this deployable artifact, this thing that you can use in your real world scenario or your real application. A Docker container with a machine model, like with a machine learning model that you can access via an API or something like that, that is a deployable artifact. That's a thing that you can use. So from that point on, the process of deploying that to a location where it can be used by your application, and then even further than that, the monitoring of how it's performing, that is very, very analogous to the way we do software development.
Yeah, and data scientists often, whenever they create a final output for a predictive model, or they do some sort of descriptive statistics on historic data, often that looks like a CSV file that's a series of, yes, like good or bad, thumbs down, or it's a static output of some sort of Jupyter notebook, or a business report that they then turn into their manager. And that's, that might be useful for a specific kind of business problem, but for a real live application, it's not production worthy.
Makes sense.
Yeah, you can't give a developer a CSV file and just be like, hey, run with that as the back end of your application.
We do not like CSV files, right?
Well, one thing data scientists don't like is configuration. One of the dreams of containerization might be that once I've built it and I have my image, and maybe I need to specify how you configure it, environment variables, all that kind of stuff, a nice README file. But after that, I can hand it to a DevOps person, say, here, it's your problem now. What's the minimum DevOps a data scientist should know? So
the DevOps movement kind of has led to this environment where the ideal scenario is that there is complete ownership of what runs in production by the team or the person who wrote it. So if I write some code, I run that code. I know what's required on the machines to run it. I know what's required on the infrastructure. I know how to get telemetry out of that thing. I am responsible for that code that I've written in production. So the ideal scenario would be that the data scientist knows how that model actually operates in the real world. Like, DevOps is kind of this movement where you no longer throw things over the wall to the next team and say, now it's your problem. So I think that requires a lot of, very close working together with all of the teams. So I think even just being aware of what happens when I put this thing in production, that seems like a minimum to me, but they may not necessarily be, completely experienced with all the configuration variables and the size of the VMs and the Docker containers and the Kubernetes cluster and the Helm charts and like that stuff. Yes, other people can definitely help with that, but some idea of how this is running in production, I think, is necessary. Yeah.
Perfect. And also, if you build a collaborative partnership with your DevOps team and your software engineering team, you can start making data-specific requests. So say there's some particular data field that you would love to incorporate into your algorithm, but we don't have telemetry on it right now. If you do have that close partnership, you might be able to, insert some sort of additional piece of the software application that can give me valuable insight into how my users are operating, and that could give me a much more performant model. So it works nicely both ways. We can help each other out really, really, really well.
So for that common use case, if I build my model, I put it in a container, we can scale it up in the cloud, works pretty well, but now there's a lot of ambitions to deploy elsewhere, deploy to the edge and things like this. What are some of the unique challenges and the solutions people have to find to deploy to so many different places?
Well, this was one of the really cool things that came out of the build keynote this morning, which essentially they were running a trained model in a Docker container, but on a device on the edge. So the container itself was running inside a camera and matching, that model with what the camera was seeing. So it was, without going to the cloud, without going anywhere else, it was identifying, a crack in a pipe, I think was the example. That kind of stuff, just completely opened a new world in my mind. Now we don't have to, call back to some highly powered machine to run through this model to make sure it gives me the result. We can use streaming video that is using this model, which is just deployed to this device. That, in my mind, is crazy. Set their mouth open for a bit.
And that's one of the lovely things about models once they've been packaged up into a container. If you're training a model, you need often gigabytes, terabytes of data. You need to have a high-end machine in order to do all of the training itself. And then for the retraining process, you might need to scale it up with some sort of cluster. But once the model's been created, once you've decided on that final iteration and you've deployed it, that's actually very, very small. It's usually only, megabytes in size. And that means that it's a lot easier to port to wherever you need to, especially as, devices are becoming more and more performant themselves. So it's exciting. It's an exciting time to be a dev and an exciting time to be a machine learning person.
Yeah. You make two good points. One, that you're right, models, the end result is usually relatively small compared to the effort to build it, and that end devices are getting more powerful. But I feel like we're still in this gray area where my model might be too big for what I might want to deploy to. Can you talk a little bit about the developer experience working through issues like that?
Sure. So an example could be that if your model was too big to place on an edge device, so say for whatever reason you wanted to have a system of surveillance cameras, and those surveillance cameras were tasked with finding specific people, so doing identity verification. You might architect a solution where not every frame would be sent back to the cloud in order to be analyzed, but you could have motion detection or even a lightweight OCR model to detect faces. And then if a face was detected, send those frames back to your cloud solution to get the identification piece. So you have to be kind of clever in the way that you architect out your data science and machine learning solutions, or at least that's an effective move that I've seen to date. There are some options. Maybe you might be able to reduce accuracy. You might not have the accuracy that you desire, but you would be able to get your model into a less complex state by removing some sort of the layers.
Naturally, the container is the nice interface, place where we can hand things off and scale them up and manage them. There's a lot of paths to that container. Can you talk about some of the typical steps a data scientist goes from, their Jupyter notebook to turning that into some actual REST API product? What are some of the choices they have?
To package up your model into a Dockerized container, you would probably create something like a schema.json file for your inputs and outputs, and that's just defining I would intake a JPEG, or I need, 4 different variables of these types. And then you would specify what your output would be, and that's usually some sort of classification and a confidence level. So Republican, 75%, or Democrat, 92% or something of that nature. The Python script or whatever language that you choose script to initialize and run the model would just do that for any added input. You would probably need some additional container artifacts depending on your choice there. And then that's basically all that you would need to do. So I recommend RESTful services. I know a lot of people like gRPC because they're more performant, but RESTful services are kind of nice for developers as well, right, Damien?
But well, from a developer point of view, it's nice to hit an endpoint and get a response in a
Right.
serializable, deserializable format. This is the tricky thing then where we kind of overlap, right? The Flask or the endpoint that's exposed inside the container, I'm all over that. The actual running the model from the Python script there, I don't know how that bit works. But the endpoints and exposing them through Docker, that's like any other application. It's an isolated microservice that you can deploy somewhere. And if it's RESTful especially, it's very easy to use something like Kubernetes to do the orchestration and scaling and things like that. Azure's got some awesome stuff around Kubernetes, and I think that was one of the announcements today was the Azure Kubernetes service. And that's a whole different podcast that could be hours long, the stuff around that. But Azure has some awesome stuff around that. And then, as long as there's a container with an exposed endpoint, you can run whatever you need inside that container, and then any application can make use of that.
Serverless is an interesting option. You kind of do have to choose that over a Dockerized approach.
Yeah.
Do you guys have any best practices for picking which solution is the right model deployment way to go?
Look, I'm coming at it from an application point of view, and I like as little infrastructure around the code as possible, or I like to offload the infrastructure as much as possible. So, running your stuff on bare metal machines isn't as good as running it on a virtual machine where other stuff's taken care of for you. And that's not quite as good as running on Docker where the OS and everything is taken care of for you. And then that's not as good in my mind as, a cloud native stuff like serverless where you don't have to worry about the OS that's running either. Like you don't have to worry about any of that stuff. You just give it your code and it works. That's my preference, but this is a very developer perspective, I guess.
And actually, serverless would be my favorite as well, just from kind of a cost perspective too. Being able to run your model just kind of on an ad hoc way whenever something gets pinged, or there's some sort of trigger for that serverless function. I think if you're deploying something to maybe an edge situation where you don't necessarily have a robust connection to an internet source, then a Dockerized approach would probably be wiser.
Yeah, that's probably a good point. Serverless obviously assumes that you have access to like the cloud or a cloud or something like that. But if you're offline, like a camera in a warehouse or something like that, you'd still want that to identify the stuff you want it to identify. And then a container is a great way of doing it.
Paige, I'm curious if you've seen any trends in how machine learning people and data science people are picking different tool sets. Is there a migration to there's so many ways we could build a model. What are some of the trends going on right now?
That sounds like kind of two questions. So tools for developers versus tools for data scientists. Developers and data scientists don't really use many of the same tools at all. If you're a data scientist, you're probably using Python or R, which means that you're probably really deep in Jupyter notebooks. You really like RStudio. If you're an R person, very interactive and very visualization focused, very iteration focused, very dynamic. You want to be able to see outputs for any code changes that you make immediately. If you're a developer, you're probably in Visual Studio or go for it, Damien.
Yeah, or VS Code or something like that. But just because you're using different tool sets doesn't mean that, there's no overlap there. Like Visual Studio Code is like a massively popular like development environment for people in any language, and I think there's awesome Python support for VS Code, and I would almost assume there's an extension or something for R in VS Code. I don't know for sure, but there's thousands of them. So
yes, and VS Code is actually the default editor now for the Anaconda distribution, which is one of the best collections of data science tools and sort of package standardization and package management that you have in the data science world. And there are AI tools for VS Code and Python extensions for VS Code too, especially on the Jupyter Notebooks side. So I'm really excited to see what we do there.
Well, to wind up, I want to pick your guys' brains about the idea of commoditization of AI. Many years ago, you wanted to do some machine learning. You hired somebody with a PhD who came and built an algorithm and did everything end to end, and better tooling, better support. All these things are making it easier and easier to the point where realistically, a developer could do an enterprise solution using image recognition and not know what a convolutional neural network is. Maybe. You still need somebody who knows some deep learning, but to what extent is changing? Where are we going? Are all problems just going to be in AI be solved with tooling, or are there certain things we will always need a human there applying some specific knowledge about?
I think the fact that I would be able to do a tool to grab images from my camera and identify what they are as a developer who definitely does not really know what a convoluted neural network. Did I get that right?
Yours is better.
Convoluted one? Yeah. I think that says a lot, but I'm well aware that that's kind of my entry level, thing. I can hit these services, and as you said, they're kind of a commodity. I can say to Azure's Vision API, hey, what's in this picture? And it's probably going to give me an okay result. It's getting more accessible for a developer like me to understand this stuff. But once you get into deep learning and things like that, then I'm a little bit out of my depth at the moment, pun intended. Yeah.
So for specialized use cases, I think you will need to have dedicated data scientists or machine learning practitioners. But what I would love to see is the idea of kind of a cognitive services or model services marketplace, where, so say you have an instance where you have a data scientist who is working to create a model to predict the amount of fertilizer needed by a rose farmer in Arizona in July or something. Like this very highly specialized use case. Since we have the ability to package things up as containers and to deploy them as RESTful services, wouldn't it be awesome to be able to market your algorithm as a data scientist to whoever wants to use it the same way that they would use one of our standardized cognitive services? If you could build that, right? And if you could build a standard hub for components of models, TensorFlow Hub is a great example. So much of model building is based on the data that you're able to acquire and use. I think that would be a lovely way to commoditize data science and machine learning. But it just takes a special human to create that space.
All things in time, I guess, huh? All right, well, to begin with, can you guys both state your names and your roles?
My name is Donovan Brown. I'm a Principal DevOps Manager for Microsoft. I run the DevOps portion of the Cloud Developer Advocacy team.
Yeah, and I'm Damien Brady. I am on Donovan's team, so I am the DevOps Cloud Developer Advocate as well, focusing on that kind of stuff.
So we're going to talk specifically about DevOps for database.
Okay.
That's a topic that's evolved a lot over the last, I would say, 2 decades. What do you see as the current state of DevOps, and are we headed in any new directions with that?
I think what we are is we're maturing to the point to where we know how to deploy our front ends very rapidly. But
Sure.
There's this dirty little secret that we still run manual SQL scripts to update our schema or to massage the data, although our pipeline is only doing a portion of our application. We want to now have our database as part of our pipeline. So I want to be really clear that we're not talking about having a pipeline for your front end and then a separate database DevOps pipeline for your back end. We want your entire solution to be deployed as a unit, and a lot of people are finally maturing to the point to where they want to incorporate their database as part of that one single pipeline of deployment. To do that, depending on what database you're targeting, you have several different options. If you're using SQL Server, then you can obviously use SSDT, which stands for SQL Server Data Tools, which produces an entity called a backpack or a DAC pack. A DAC pack is just the schema of your database. Think of it as a digital fingerprint. It knows what your schema is supposed to look like. You can then give that DAC pack to a command line tool and point it at any SQL server in the world and say, go make that SQL server look like you. It'll figure out all the Ultra scripts necessary, and at runtime, modify your SQLs, your store procedures, your tables, your triggers, your functions, the entire schema to make it match what your destination or what your source is supposed to look like. It's really cool. And you can actually do that as part of your DevOps pipeline. So a stage of your deployment is, go deploy my new schema of my database. But if you go outside of that, you need to do what Flyway, Liquibase. There's lots of other products out there that can help you target MySQL, Postgres, Oracle, and things like that.
These are tools for SQL Server specifically as well.
Not the last
Sorry,
ones,
the last few,
yeah.
but there are tools for relational databases in general, right?
Yes.
So then you get into the whole idea of unstructured data and like data tables and NoSQL, things like that, which have always kind of promised, at least like from the developer's perspective, they always kind of promised you don't need to worry about the schema, you just start writing new documents to your document store, for example. Right. But in practice, it's a little bit harder than that. You've got to start thinking a bit more about your architecture of your application. what happens if I'm writing different documents? Will my application be able to read the old version of them, or is it just the new ones? Or so then you start talking about versions of APIs that talk to those databases and things like that. It gets a little bit more complicated once you get down in the dirt with some of these updates and things like that.
What if I need to roll back? Which is always a question people ask. And when you start doing database, when you add your database to your DevOps pipeline, the rollback becomes far more complicated.
Yeah.
Because you can't roll back data. You can't roll back the schema as easily as you can the files of a website. So a lot of people are adopting two different methodologies. One is you make sure that your database backend can support the current version of your app and the next version of your app. That way, as I'm deploying the next version of my app, if I do have to roll back the front end, I don't have to touch the back end because it can safely support both the current version and the next version. So if you want to do something like drop a database column, it takes 2 releases to do that. Because you can't just drop it and deploy the new version, because if you rolled back, the old version would expect that column to be there.
Right.
But if you actually did it 2 releases away from today, which means I release a version that doesn't need it, I release another version that doesn't need it, now I can safely delete that column, because even if I rolled back to the previous version, it doesn't expect that column to be there. So those are the ways you have to think through, like almost 2 or 3 steps ahead of where you are to make sure that you're not going to deploy yourself into a problem when you roll back. Think about those considerations as you're building your pipeline, because it's not, once you add the database to this situation, it becomes far more complicated.
Sure. I'd love to dig in more on the idea of deploying as a unit. So I've been in a lot of situations where you deploy, a web server, maybe an API that goes with it, some other microservices, but the database rarely makes its way into that group. In fact, I think of a database as something that a lot of organizations are a bit afraid to touch, actually.
Completely agree. And the reason that they're afraid to touch it is because the changes to it can be catastrophic.
Sure.
Right? It is literally holding the thought, the brains, the truth of your application is stored in that database. To mess that up is something that could be catastrophic.
Yeah.
So there's a lot of fear involved. And the reason that there's a lot of fear is because historically, there hasn't been a good way of doing it. It's always a series of manual scripts being concatenated together, blessed by a DBA, and then manually executed. And when hell breaks loose, it's some poor person trying to fight their way out of this scenario. But when you start to trust the tooling better, and you start to realize that you need to treat your database like you treat every other part of your application, it makes sense to put it as part of your DevOps pipeline. And why would I send a human being to do a job a machine could do so much better if you simply trusted the tooling? But the tooling, again, has matured so well, but we still have this distrust from the tools we had in the past. And we need to break down that and say, hey, look, you need to take a new look, because you're the only risk for me, right? The human beings, I can track down every failed deployment I've ever been a part of to a human being doing something they weren't supposed to do or forgetting to do something that they were supposed to do. But when you automate it through a pipeline, it happens every single time.
I'd love to go into the alter situation you were describing.
Sure.
If you've got a nice dev environment, a lot of unit tests and that sort of thing, you might have an alter statement that runs just fine on an environment that has no real concurrency going on, no load, and then go to run in production where the table is not 1,000 rows, it's a couple million, maybe 1 billion rows. That alter is going to take a while.
Sure.
And that could be a surprise if you haven't planned for it.
Correct.
And that makes it feel like it's still a process I want manual oversight on. What are the tools doing today that are innovative enough that I can hand off some of those responsibilities?
You want to have a pipeline that has more than just 2 stages in it. I don't want to have a stage that, here's this empty, happy, perfect path database that I'm going to be able to alter. I would have a staging environment or a QA environment that is production-like as you possibly can, such that you can test those long-running alter scripts and know that maybe we don't need to do an alter, maybe we need to do something magical or disable our concurrency for a moment, whatever you have to do to make that a faster change versus trying to keep all the integrity. Because we've done crazy stuff like turn off all data integrity for a second, make the change, which is now an instant, and then enable that again can sometimes be much faster than having the database do it itself. So you wouldn't know that unless you had an environment where you could test that and verify that, yes, this is going to take a long time. Let's go ahead and put the precautions in place. But too many people aren't creating a series of environments that become more and more production-like so that they can find those issues earlier.
Yeah. So how does a small organization adopt to a strategy like that? Somebody who looks at a series of environments and thinks, gee, do we have the manpower to stand all that up?
Oh, that's a good question. I would start to lean towards infrastructure as code. And if you start to move to the cloud, that becomes less scary. Because if I need to have 5 environments in the old days, that's a lot of iron.
Oh, yeah.
Right? That's a lot of money. And it sits around idle for the majority of the time. But what if, when I needed a staging environment that looked a lot like production, It only needed to exist while I needed to test in it. I could use infrastructure as code, which is a DevOps best practice where you codify what the environment should look like. And at a moment's notice, spin that entire environment up and hydrate it, be able to populate it with any sample data we need it to, run my test on it, and then literally destroy the entire environment. I'm no longer billing, I'm not paying for it, and I don't have this iron that is just this liability in my data center anymore. I literally use it, destroy it, and the only long-living environment is production itself, which should hopefully still be hosted in the cloud, still using infrastructure as code. So you're applying these DevOps best practices in every single environment that you have. And because they're non-production, if you don't need them anymore, you can literally delete them. So a smaller company can actually leverage this just like a big company can. It's just their environments will be smaller and maybe even shorter lived, but you don't have to treat yourself differently because you're small. You should be doing the exact same DevOps best practices regardless of the size of your app or the size of the organization.
That's exactly right. Yeah, infrastructure as a service is the way to get this stuff up and not have to worry about managing that the entire time.
Absolutely.
The other thing that you can look at as well, especially with large monolith apps that have one database that's shared by 30 services or something like that, is one of the microservice kind of best practices, which is to break the data up into just what that service needs.
Yep.
So you're not modifying the entire database that's going to affect all of these different parts of the application. You're deploying a change to the customer service, which changes the database that's behind just that customer service. You know, by changing just that small service and separating those databases out into the small microservice-based things, you can kind of reduce the difficulty of doing these things. It doesn't remove any of these problems. It just makes it slightly easier to reason about if you separate the database.
And another thing, you kind of made me remember something else that I tell a lot of our customers. When we start talking about DevOps with them, you can always see that glimmer in their eye that my answer is going to be, you just get the right tools in place and it's cake, right? And that's never the answer, right?
Yeah.
Many times you have to re-architect your application such that you can deploy at the speed that you want to deploy. There might be a re-architecture required for you to be able to utilize the process that we're talking about, but the gains and velocity that you get are well worth the investment that you're going to have to make. And it kind of leads to what Damien was just saying before. That's a re-architecture, right? To be able to move and to use the tools effectively, it wasn't just bolt them onto my existing application, bolt them onto my existing schema. It was rethink about how we're designing our application such that we can move at the speed that we want to move in the future.
So I'd love to delve in a little bit more to SSDS. What are some of the...
SSDT.
Sorry.
SSDT.
Yeah. SQL, I'll explain it. It's SQL Server Data Tools.
Yeah.
That makes it a little easier to remember. And there was all these tools to help a database developer feel more like a .NET developer, like have the tools, be able to use source control, be able to version your schema, be able to do refactoring, which is one of the coolest features of SSDT. What you would do is point it at that existing database and say, import the schema for me. Then it understands the landscape of your database. You can then go and right-click on a column and say, rename this column. It will find every stored procedure, trigger, function, cluster, everything, and fix it for you as well. It's amazing. Or if you were to go make some arbitrary change and not use the refactor feature and just change it yourself, if you build, and it's a logical build, right, because you don't build a database, but they have a concept of a build where it will go and verify, will everything in your database still work based on the changes that you currently have in your schema? So SSDT gives a database developer the same power as a compiler gives all of the developers who program in a normal compiled type of language. It gives you refactoring, it gives you database deployments with DAC packs, it gives you unit testing. I mean, it's just, again, imagine giving all the power that a normal .NET developer has and giving all that power to a database developer. That's what SSDT does. When I introduce SSDT to people and they see the project inside of Visual Studio and they see all this DDL, they get nervous. You're like, oh man, I couldn't write a create table by hand, from scratch, right?
Not the one you see come out of this.
Exactly.
Yeah.
I would go into SSMS and I would add my table and it would all be nice. Exactly. So what's really cool about this is you can do it either way. If you are a DBA and you can get in there and you can write it from scratch, the database project will let you do that. Me, I would never do that. I would go into SSMS, I'd fire up my database, I'd make my changes right there like I know how to do it using a graphical user interface. Then you can go back into the project and say, I need you to compare the schema of my actual database where I've been working to the project that everyone else is sharing. And then it will go in and it will update all of the objects for you so that you can commit your changes as a unit, but you're not forced to write DDL right there inside of the application, which is pretty cool. So you work however you're comfortable, and then we take care of the rest for you when you check it in, which is another cool benefit of SSDT.
That's interesting. I do it the other way.
Do you?
I write SQL. If
Wow.
I will look at a table, I'm like, okay, I need to update this column. And so I will sit there and I'll write the SQL, I'll run it, make sure it works okay, and then I'm like, right, that script is now my change script. So these two methods you were talking about, they're like model-based SSDT, here is what my database looks like, and then the migrations-based approach with ReadyRoll, for example, and
Entity Framework does it too.
Entity Framework Migrations does that as well. That's where you explicitly say, this is my update script. This is my script that I'm going to run. I work that way.
I work even when I'm using Entity Frameworks. I just did this the other day. I moonlight and I have a project where I had to go add a column to a database. I did not write my migration first. I went inside of SQL Server. I made it work, and then I ran. There's a PowerShell command you can run, said add migration, and it read my database schema, looked at my data models, and said, oh, these don't match anymore, right? And then it fixed it for me, right? So I never write SQL.
Well, that kind of highlights the point, right?
Exactly.
We both work on the same kind of stuff.
Yeah,
in different ways.
Exactly. So whatever we meet the developer where they are, right? I would never trust myself to write SQL ever. I always expect the tool to write it for me because I know they're going to do a better job of it than I would. So that's awesome. Yeah.
So to wrap up, there's a lot of tools out there for CICD.
Yep.
A lot of open source, a lot
Absolutely.
of commercial. What does Microsoft bring to the table that's unique?
What we bring to the table that's unique is we have a completely agnostic offering, which is very unique from Microsoft because historically we've always been .NET on Windows.
Sure.
Right? That's all we did really well. And that did not serve us very well because the industry started going more open source. There's a lot of Java development. Languages are popping up all over the place, Go and Rust, and every week there's a new language. And you can't expect all the developers to always be cookie cutter developers and always do it the same way. I joined Microsoft, and for the first time ever, I installed Linux. Think about that. I joined Microsoft, then I installed Linux, which is really weird.
And you still work here.
Exactly. But I had to. It was so weird is that I had to learn how to install Linux because our build system worked on Linux. Because we can build programs that are on Linux. We had to start working with Docker, which was on Linux. So I had to learn Linux. I have a MacBook, right? And I have a Mac Mini at the house. And it's like, how do I work at Microsoft? And I own all these other products. And it's because we're insisting that we're going to go meet the developers where they are on their Macs, on their PCs, and on their Linux machines. And I think we're embracing this whole open source mindset. Because, for example, our build system, like you said, there's lots of CI systems out there. Ours is an open source. You can likely go read the source code for our agent that does the build. So we're learning constantly on how to use our own dev tools really, really well.
That's outstanding.
Oh, I think it is.
Yeah, definitely.
Cool. Well, thank you guys so much for coming on and sharing your expertise.
Thank you so much.
Cool.
Thanks for having us.
Yeah.
Thank you.
All right, everybody, thanks for listening to the end of the show. I want to get some listener feedback going. I myself am making some decisions about DevOps recently. Maybe sometime next year you're going to hear about what I'm currently building. But I want to hear from you guys. How have you deployed your models to production? What tools have you used? What were the challenges you faced? I'm looking to collect data science deployment stories. If you've got one, write me up a 2-paragraph pitch, no more than 600 words. Guys, you got to keep under that limit. I'm just not going to read them if they're over that. 600-word limit. Send them my way to Kyle@DataSkeptic. I want to hear what makes your story unique and interesting. The top couple of stories are going to be the first people to get our new theme t-shirt. We'll feature your story and perhaps your company on our blog, and maybe even get you on the show. So if you're opinionated about how one should release models to production, 600 words, Kyle@DataSkeptic.com. Go.
Data Skeptic is a listener-supported program. To support the show, visit dataskeptic.com and click on the membership tab.